Good morning, students. Welcome to Environmental Science as taught at MIAT College of Technology. My name is Robert Powell. You can feel free to call me Bob. I'm quite used to lecturing in front of students. I've been doing it for about 4 years now, but I'm far less adept at speaking to a camera and envisioning my audience, period. There are some limitations to this approach because I can't see your faces. When I'm teaching a class in person, I can usually see by looking at the students' eyes whether or not they are understanding the materials that are being taught. In this particular case, I'm afraid that you will need to let me know in some way or the other if you are not getting it. And if you are not getting it, I will do what I can to help you. During the course of this video, you will see me looking upwards. That's because I have a number of topics I want to cover, and making certain that I don't forget to cover some of them, I've made a series of notes that I'm showing on my external monitor as I record this on my MacBook Pro. Briefly, environmental science is the study of everything around us and your place within it. That includes all living things, all non-living things, and all our interactions with our environment. Biology is incredibly important for this course, so I urge you to think back on what you learned in your biology courses during high school, perhaps junior high, and thinking how that applies within the context of environmental science. Because if you think about it, if the Earth were a barren, lifeless rock, there wouldn't be anything to study except geology, and there wouldn't be anyone here to study that. Because Earth is the only planet that we're aware of that has life, it's incredibly important for us to understand how we interact with other life on this planet upon whom we are utterly dependent for everything, and to make certain we don't damage the systems upon which we depend. This is a series of things called ecosystem services. The most common one that you've probably heard of are such things as honeybees pollinating 60 or 70% of our food crop. Clearly, it's important that the honeybees don't all die out. And we will cover many topics like this during the course of this semester, or this quarter, as it were, at this school. Forgive me if I drop back and forth like that. I teach semesters at Washtenaw Community College. So first of all, let's talk about some of the course details, since this online format is new to most of us. Many people are wondering what was due during week 0, what was due during week 1, etc. The best way to clear this up is to look on Canvas and look at the modules section on the left-hand side of the screen of your browser. As you go into the modules, you'll see what's expected each week, because each module represents one week of the course. So we are, or have been, in module 0. As you see this video, we should be in module 1, which is week 1. I also want to mention that in module 0, you'll find a link to the electronic textbook. One great thing about this class is that you no longer have to pay extra for a paper version of the textbook. That's a big plus. Each week's module typically has an assignment and a discussion. You will be responsible for getting these done, and you will be responsible for getting them in on time. On time means before 11:59 p.m. on Sunday, that the week of that module. So, for example, if you have an assignment and a discussion you need to do for week 1, you will need to make sure you have them in next Sunday by 11:59 p.m. because at midnight we begin the next module, midnight Monday morning. You need to get them into me because I'm extremely busy and there's no going back to grade late assignments. That's just the way it's going to have to be. We have an entire week to get these done in, so certainly you should be able to find some time during that week to accomplish your tasks and discussions. Occasionally, there's a 30-point direct instruction reaction where you evaluate what I said in the video. For example, if we had one for week 1, you would watch this video, review what I said, tell us what you learned from it, what you wish I had said in additional detail, and so on. We don't have one for week 1, but there will be one for week 2, and these are worth 30 points each. Specifically for this week, week 1, and assignment 1, you will need to read chapters 1 and 2. Chapters 1 and 3 for week 1. Make certain that you do that because it will make it far easier for the discussions and the assignments if you do that. In addition, for week 1, I've posted 2 videos within the assignment. 2 of them are about, let me go back a second. I told you I'm not super good at doing this on camera. I've posted 3 videos in assignment 1. The first 2 videos are on evolution by natural selection. They're incredibly good videos for explaining this, probably doing a better job than the book, but at least they will reinforce what the book is teaching you. And they will help you answer question 1 on assignment 1. I've also included the TED Talk by Dr. Lucian Walkowitz for you to watch and think about. That's all I'm really asking you to do, is to watch it and think about it. I strongly encourage you to watch it. She is a fellow at the TED organization, and she has important things to say. It'll help you understand the importance of being part of the environment and trying to make our interactions with it less harmful. She makes some very good points, and I particularly like her possible solution to the Fermi paradox. It's a bit frightening, however, if you think about what she is saying, and I think you will enjoy the video. Regarding the first discussion for our week 1, human beings as Homo sapiens sapiens, that is the genus Homo, the species sapiens, and the subspecies sapiens, have only walked the earth for around 200 to 250,000 years. In terms of evolutionary speciation, creating distinct species, this is a very short time, particularly for K-type species such as humans. In brief, K-type species are species that reproduce fairly slowly because they bear very few young and take care of those young over fairly long time periods. You might think of humans, elephants, animals like that breed slowly. This tends to result in slower changes to the species due to natural selection than would occur for faster reproducing species. Organisms with very fast reproduction rates are called R-type species. I always think of it as R equals reproduction, fast reproduction. These include things such as bacteria, mosquitoes, roaches, ants, etc. Typically smaller animals, no care for their young, and so on. When this occurs, they can generate both mutations and randomized mixes of DNA much more quickly than, say, humans and elephants. This allows distinct speciation to occur in those groups far more rapidly. And in fact, we see a great deal of this with regard to bacteria and antibiotics. Many bacteria, due to evolution, have formed new species that are now resistant to almost every antibiotic that humans have created. This is because of their ability to reproduce quickly, exchange DNA rapidly among themselves, generate mutations, and so on. So, therefore, in the statement of the discussion, share an example of a living thing that had to adapt to the changes we as humans have made to our environment. That statement might not necessarily include a distinct change in a species from a species into a new species, but it can also include things such as behavioral adaptations and so on. However, some species have genetically adapted through natural selection due to environmental pressures we've exerted on the environment. A discussion of either type is acceptable, but bear in mind this latter type that has actually undergone speciation are usually going to be the smaller, high reproductive rate R-type species. I just gave you an example. The mutations in bacteria into new species due to the selective pressures from our antibiotics. That's really all I have for now. I strongly encourage you to read chapters 1 and 3 right away. I also encourage you within chapter 1 to look at the figure that shows all the various types of science, economics, politics, and so on that feed into the topic called environmental science. Additionally, I encourage you to study the scientific method and perhaps think of ways that you could apply the scientific method, which is a self-correcting approach to science, in your everyday life. I wish you the best of luck with assignments during week 1, the assignment and the discussion, but you won't really need luck if you read chapters 1 and 3 carefully and watch the videos. I'd encourage you to get in touch with me if you have any questions. It's easy to contact me by email. You can also call me, but leave a voice message if you do, because I don't answer unknown numbers. You can also text me. So feel free to contact me if you have any questions, and I will do my best to make this course work out well for both of us. Thank you very much.